This is the Stirrup Consultants problem. Here we have the data that they've collected about the recruiters for the school. Before us, we're looking at the years of higher education that the recruiters have, their years of experience, their age, how much of a bonus do they get for each recruit that they make, the number of calls per day they make, the number of emails per day they make, and the number of recruits per month that they get on average. The company has asked you to analyze this data and figure out what is it that lends the most, that gives us the most impact on recruits per month. So what we're going to do here is a multivariate regression where recruits per month are the thing we don't know. Everything else we can control, right? We know all of the facts about our recruiters. We get to set the bonus, and we can tell them how many calls a day and how many emails a day on average to make. So let's do our regression. And our Y, our dependent variable, is recruits per month. And our independent variable is everything else. We have labels, and we're going to run our regression. Our first R squared is 91%, 91.5%, which is really good. But our p-values are a mixed bag. We have a p-value of 0.99 for the intercept, which means it's almost positive that there is no constant for this equation. Our p-value for years of experience is 0.45. But the p-values for everything else looks pretty good. So let's redo the regression, getting rid of the constant. Data analysis regression. It should save everything. All I have to do is say constant is 0. My R squared is 98%, which is even better, actually. What was it before? Was it 91? Yeah. So 98% is even better. From, I keep saying p-value, R squared, I'm sorry. When we look at our p-values, with a threshold of 0.05, all of our p-values are below the threshold. I'm sorry, I was looking at lower 95%. When we look at our p-values, our threshold of 0.05, all of our p-values are below 0.05 except for years of experience. It seems that years of experience has a very good chance of not being related to the number of recruits that someone gets. So let's do the regression again. But this time, let's eliminate years of experience. That's the easiest. I could rearrange the columns, but the easiest way for me to do it is to do that. So my Y range is the F column, and my X range is everything else. Okay, and my R squared is 98.27%. My p-values 0.009, 481 times 10 to the negative 11, 5.9 times 10 to the negative 249. So the thing that we know is most certain to have an impact is a recruitment bonus. Now, for each extra dollar of recruitment bonus, you only get a 0.004 of a recruit. So you're going to need to at least be talking $1,000 per recruitment bonus in order to have, or I'm sorry, $250 to get an appreciable impact. But we can see that recruitment bonus, age even has an impact. The older the person is, the lower the number of recruits they're going to make by a bit. So I guess students want to be recruited by people more closer to their own age. Calls per day has more of an impact than emails. And years of higher education does have an impact. So the equation that we would be looking at is recruits per month is equal to 0.448 times years of higher education minus 0.019 times the age plus 0.004 times the bonus plus 0.04 times the number of calls per day plus 0.019 times the emails per day. I put this little tick in front of it so it doesn't treat it as an equation, it'll just display it. So that's my equation, and that's my analysis for my regression.